am Madam Gracious Kanzieni from Educare TZ. Warmly welcome in our media Educare TZ, so you can proceed with our chemistry subject in Form 5 level. And our tutorial in this chemistry, we are dealing with the physical chemistry in the concept of relative molecular mass in solution. This is our second subtopic in the physical chemistry. So my student, for today, we're going to look on the vapor, pressure, and Raoult's law. As in the previous session, we tried to look on vapor pressure lowering as we tried to discuss in colligative property. And then we discussed that the colligative property divided into 4 main categories. Which are lowering vapor pressure or the vapor pressure lowering, but also there is freezing point, depression, boiling point, elevation, and the last one is osmotic pressure. So we are required to know and to understand each category and how it can be applicable in the determination of molar mass of the solute in this solution. Okay, in the previous session we tried to look on the vapor pressure lowering, and we try to look on the formula, what does it mean, and what the vapor pressure lowering. Tukaona ni difference iliyoko kati ya ile pure vapor pressure of the solvent and the pressure of the solvent in the solution, or the pressure of the solution. So that is all about. Tukaona kwamba change in P is equal to P degree minus P, ambapo P degree ilikuwa inamaanisha ni pure vapor pressure of the solvent, lakini pia NDP ile ambayo haina nani yoyote tukaona kwamba ni pressure of the solution, na change in P ile ilikuwa ni change in vapor pressure. Now today we are proceeding in that concept of vapor pressure lowering, but we are going to look in the vapor pressure and Raoult's law. Remember, during tumeanza discussion in this session tusema kwamba tutasoma this colligative property, lakini kuna mainly law which govern this colligative property. Sasa kama tumeanza kusoma concept ya lowering vapor pressure, mean that we have to look on the laws which govern this colligative property or this component of law lowering the vapor pressure. Okay, now here we are going to look on the vapor pressure and Raoult's law. So let us see a little bit concerning the Raoult's law. What does it mean? So this Raoult's law was named after a French chemist called Francis Marie Raoult. Na hawa ni wataalam, kwa hiyo ndio maana hata unaona kwamba the law is like the name of someone. Huyu ni French chemist ambaye alikuwa na jina lake alikuwa ni huyu hapa Francois Marie Raoult. Kwa hiyo from here ndipo law ikapatikana ikaitwa Raoult's law, ambapo ilikuwa ni katika 1430 mpaka 1901. Kwa hiyo iliandikwa, kwa hiyo we have to study it. Okay, so in the 1890s, Raoult discovered that when a substance is dissolved in a solution, the vapor pressure of the solution decrease. Sasa huyu Raoult katika kipindi cha mwaka 1880 aligundua kwamba when a substance is dissolved in solution, the vapor pressure of the solution decrease. Kwamba pale ambapo substance inakuwa dissolved kwenye solution, vapor pressure of the solvent tend to decrease. Remember, solvent ni kitu gani? Solvent tushasema ni ile substance ambayo ina dissolve the solute. Sasa anasema kwamba when a substance is dissolved in a solution, kwamba substance dissolve kwenye solution, the vapor pressure of a solution tend to decrease. Vapor pressure of the solution decrease pale tu ambapo kuna dissolution of the substance. Substance ikidissolve, vapor pressure yake ina decrease. Sasa huyu ndipo alipokuja na hii law. Sasa yeye alidiscover hiki kitu. Then we can see that he further observed that the decrease in vapor pressure of the solvent in a solution was dependent on the amount of solute dissolved, and hence the mole fraction of solute and the vapor pressure of the pure solvent. Sasa sio tu kwamba aliona kwamba when the substance is added in the solution or is dissolved in solution, vapor pressure of the solution decrease. Hajaona tu hilo, bali anasema kwamba he further observed that, aliobserve zaidi kwamba the decrease in vapor pressure of the solvent in a solution, ile decrease in vapor pressure of the solution ile decrease of vapor pressure of the solvent katika solution ina depend na vitu vifuatavyo. First, it depend with the amount of the solute dissolved, kwamba cha kwanza ina depend na amount of the solute ambayo imefanyaje, imedissolve, and therefore hence the mole fraction of the solute and the vapor pressure of the pure solvent. Kwa hiyo ina depend kati ya hivi vitu number of solutes au amount of the solute dissolved, lakini pia this mole fraction of the solute and the vapor pressure of the pure solvent. Kwa hiyo hii decrease in vapor pressure ina depend na hivyo vitu. This is the further observation which observed by the Rothes. That's why hata law ilipewa jina la Rothes law. Okay, anasema this observation were summarized into what is called the Rothes law. Rothes law, kwamba hiyo summary nzima, hiyo observation nzima ya baada ya come up with that idea, akadiscover the concept, akatry kufanya experiment, akafanya hizo observation. Kwa hiyo unaona kwamba summary nzima ikawa simplified by using the Rothes law, au tunasema kwamba ile observation nzima iliyoonekana wakati anafanya ule uchunguzi ilikuwa summarized kwa kuitwa Rothes law. So now what is the statement of the law? Kwamba sasa okay, tumeona kwamba huyu scientist au this chemist alifanyaje, alifanya a certain observation, ilikuwa summarized kaitwa Rothes law. Now what is the statement of the law? Kwamba law yetu inasemaje? Ukiambiwa state the Rothes law, what will you say? Okay, the statement of this Rothes law state that the vapor pressure of a solvent above a solution, vapor pressure of a solvent above a solution is equal to the vapor pressure of the pure solvent. Sorry, hapa utafanya conversion. Hii vapor pressure of the solvent haina hiki kidegree, lakini pure vapor pressure ndio ina kidegree. Kwa hiyo hiki kidegree utakitoa, utakiweka hapa. Kwamba alisema hii law inasema kwamba vapor pressure of a solvent above a solution, ina maana hapa ni P solvent, is equal to the vapor pressure of pure solvent ambayo ni P degree solvent times the mole fraction of the solvent. This is the statement of the law. Kwa hiyo vapor pressure of the solvent is equal to the vapor pressure of the pure solvent times the mole fraction. This is according to the Rothes law. Rothes law. So vapor pressure of a solvent above a solution ambayo ni P solvent is equal to the vapor pressure of the pure solvent times the mole fraction of the solvent. Kwa maana hiyo kwamba tunachukua P ya solute na P ya solvent mara P ya solute, P of solvent ni sawa na P of the pure solvent ambayo ni P degree mara mole fraction of the solvent. If you remember, tulisoma the concept of mole fraction wakati tunasoma the concept of gases. Tusema ile mole fraction inakuwa represented na haka kaalama ka hivi. This is symbol, it is a Greek symbol, kwa hiyo katakuwa kanatumika. Kwa hiyo unaona huku tunakaweka, tunavozungumzia mole fraction tunaweka kaka alama. Kwa hiyo kasije kaka confuse, tulisoma kule mwanzoni, kwa hiyo huku tunaendelea kukaa apply. Okay, now mathematical this statement can be expressed as follows. Sasa tumesema kwamba the Rothes law illustrates kwamba the vapor pressure of the solvent is equal to the pure vapor pressure of the solvent times the mole fraction of the solvent. Sasa mathematically itakuwa ni hivi kwamba P of the solvent ni sawa na pure vapor pressure of the solvent mara mole fraction of the solvent. Kuna utofauti kati ya hizi P, sisi kakuconfuse kwamba tunapoongelea pure vapor pressure tunaweka ka degree juu, lakini tunapoongelea pressure vapor pressure solvent hatuweki chochote, inakuwa tu ni capital letter P. Kwa hiyo P of the solvent unajua kabisa hii ni vapor pressure of the solvent, lakini ukiona hii P yenye ka degree unajua ni pure vapor pressure of the solvent. So this is the mathematical expression of the Raoult's law. Raoult's law. Now if you remember well, in the previous concept wakati tuna solve issues za gases, tulisema kwamba mole fraction always is given by n of the component, maybe it's component A over the summation, I mean NT, ambayo NT inamaanisha ni mole fraction of component A plus mole fraction of component B plus mole fraction of component C, whatever. So you can see that mole fraction of the solvent now itakuwa sasa na n of the solvent over n of the solvent 1 plus n of solvent 2 plus n of solvent 3, whatever kadri zinavyoendelea. Finally tutakuwa na mole fraction of solvent sasa na n of solvent minus n over n total. Kwa hiyo tutakuwa na mole fraction of the solvent itakuwa sasa na number of mole of the solvent over any total of the solvent. So this is simply, kwa hiyo tunaanza kufanya expression hapa, tunaanza kufanya rearrangement of our formula. But similarly mole fraction of solute is the mole fraction of similarly this one is the mole fraction of the solute. Kumbuka hapa tulikuwa tunaongelea ni mole fraction of the what, of the solvent. So can you see that hapa tunaangalia the summation ya solute and solvent, kwa sababu tunaangalia kitu kama kwenye solution. Kumbuka kwenye ndani ya solution tuna vitu viwili, solvent na solute. Therefore can you see that mole fraction of solvent sasa na number of mole of solvent over number of mole of solute plus number of mole of solute, solvent na solute. I think it is clear kwamba mole fraction of a solvent ni sawasawa na number of mole of solvent over number of mole of solvent plus number of mole of solute, kwa sababu solution tuna vitu viwili. Kwa hiyo total, total yetu itakuwa ni number of mole of solute na number of mole of solvent. Therefore tunakuja kusema kwamba sasa hapa tulikuwa tunaangalia the mole fraction of the solvent. Sasa what about the mole fraction of solute? Inakuwa ni inversely. So tunasema inakuwa ni similar, ni kitu kile kile kwamba the mole fraction of solute itakuwa sasa na number of mole of solute over number of mole of solvent plus number of mole of solute, ambayo itakuwa ni sasa na n of solute over n total. Kwa hiyo ukiwa na mole fraction of solvent unaweza kutafuta kwa kutumia n of solvent over nt, lakini pia the same tunapokuja kwa solute the same itakuwa mole fraction of solute sasa na n of solute over nt, wakati kwenye solvent ni n of solvent. Tunabadilisha tu hizi concept, lakini tunasema ni similar, ni vitu ambavyo vinafanana. Okay, so in the solution the mole fraction of the solvent is always less than 1. Sasa mole fraction in solution is always less than 1. Wakati tunasema concept of gases tuliona kwamba mole fraction 1 plus mole fraction 2 plus mole fraction 3 whatever, yote ni sawasawa na nini? Na 1, is equal to 1. So here tunaona kwamba in the solution the mole fraction of the solvent is always less than 1. Ina maana isizidi 1. Ina maana itakuwa ni 0.1, 0.2, 0.3, 4 mpaka 0.9, lakini ni less than 1. So therefore the vapor pressure of the solvent in a solution is always less than that of vapor pressure of the pure solvent. Asa pure, vapor pressure ya solvent ni less than that of the pure solvent. Kwa hiyo nataka ujue hivi vitu kwamba mole fraction of the solution is less than 1, lakini pia vapor pressure of the solvent is less than that of the vapor pressure of the pure solvent. So you can see that a solution which obey the Raoult's law at any concentration is called an ideal solution. Remember here we are talking about the vapor pressure and Raoult's law. Lazima tuone hii relationship iliyopo. Sasa tunakuja kuona kwamba tunapo consider the Raoult's law mean that any solution ambayo ina obey at any concentration, if it's obey the Roth's law, is known as the ideal solution. Na ni solution yoyote ile ambayo ita obey the Roth's law katika concentration yoyote ile, it is called the ideal solution. Ideal solution. However, most solutions deviate from the ideal behavior at a certain concentration, and the Roth's law work better for dilute solution only. Sasa tunaona kwamba kwamba hizi some of the solution huwa mostly huwa zina deviate, yani zinakuwa zipo out of the ideal solution au zinakuwa has obeyed the Roth's law. Sasa tunaona kwamba zina deviate on how, zina deviate katika the different concentration at a certain concentration. That is why this Roth's law or ideal solution it work better for the dilute solution only. Dilute kwa sababu zile concentrated ndizo zinazopelekea hizo deviation, kunakuwa na ule utofauti kunakuwa na ule utofauti ambapo tunaona some solution kulingana na ile concentration, ile concentrated ya solution tunaona kwamba ina deviate from the ideal, ina deviate from the ideal behavior, kwa hiyo inakuwa ipo opposite na Roth's law. Kwa hiyo therefore it's concluded that this Roth's law works better, yani inafanya kazi zaidi au katika ubora zaidi na ufanisi vizuri effectively katika dilute solutions only. Sasa zile diluted solution ndizo zitakazo saidia ku remove ile excess concentration ambayo itapelekea deviation. Okay, now since a solution consists of the solvent and the solute, the sum of their mole fraction is equal to 1. That means tutaona hizo derivation kwamba kama solution ina consist solute na solvent, therefore summation of their mole fraction itakuwa sasa na 1. This means that mole fraction of the solvent plus mole fraction of solute is equal to 1. Therefore mole fraction of solute ni sasa na 1 minus mole fraction of solute, kwamba mole fraction of the solvent ni sasa na 1 kutoa mole fraction of solute. Kama mole fraction ya solute ukiplus na mole fraction ya solvent ni sasa na 1, kwa hiyo mole fraction ya solvent ni sasa na 1 ukitoa mole fraction ya nani, ya solute. In simple calculation, just rearrangement of the questions. So if you substitute equation 2.3 into 2.2, you get this one. Sasa tunakuja kwenye ile equation yetu ambayo tulisema kwamba pressure of the solvent sasa na pure vapor pressure mara mole fraction of the solvent. Sasa tunakuja kuisubstitute. Sasa kama hii mole fraction of the solvent sasa na 1 minus mole fraction of solute, maana yake kwamba sehemu ambayo kuna mole fraction of the solvent tunaweka 1 toa mole fraction of the solute. Therefore itakuwa ni hii kwamba pressure of the solvent sasa na pure vapor pressure minus this one. Kwa hiyo hapa tuna substitute, tunaweka hichi kitu hichi hapa kwamba itakuwa ni this pure vapor pressure of the solvent mara mole fraction of the solute. Therefore, and rearranging you obtain this one. Sasa ukirearrange hii formula au hii equation unaenda kupata kitu kama hiki kwamba pure vapor pressure of the solvent minus vapor pressure of the solvent ni sawa na pure vapor pressure of the solvent mara mole fraction of the solvent, ambayo hii pure vapor pressure tunaona hapa kuna pressure na pressure. Kwa hiyo tutakuja kupata kwamba change in pressure, tukirearrange hapa tunakuja kupata change in pressure ni sawa na pure vapor pressure of the solvent mara mole fraction of the solute. So that is all about. So, kutokea kwenye hii question simply tutaenda kuexpress graphical. So you can say that equation show that the vapor pressure lowering depend on the mole fraction of the solute as illustrated in the figure 2.1, ambapo tutaenda kuona graphical this illustration. So the graph of the vapor pressure against the mole fraction, vapor pressure against the mole fraction. Therefore it shows that the mole fraction of the solvent decrease, increasing mole fraction of the solute, mean that ni vitu vinaenda inversely. So the vapor pressure of the solvent in the solution decrease relative to the pure solvent. So now as you can see that as a result the lowering of vapor pressure ambayo ni change in P tend to increase. Kwa hiyo ni kitu ambacho kinaenda inversely proportional. Therefore the lowering of vapor pressure change in P is directly proportional to the mole fraction of the solute in a solution. So tunapokuja kuconsider change in pressure na ile mole fraction, they are directly proportional.